Hello everyone, welcome to Roots of Unity. I am Marzukh and today we're going to cover the last part of function, which is transformation. So what are transformations? Mathematical transformations describe how two-dimensional figures move around a plane or coordinate system. In our syllabus, we're going to cover three types of transformations: translation, reflection, stretch. Right. So what is translation? It's basically moving a figure across the plane without changing its shape or size. Let's see an example now. Here is a diagram of the y equals to f of x curve, where f of x is equals to x squared. The question asks it to be translated 2 units upwards. Right? If we want to do this, well, we could simply draw this curve. And this is the sketch of the y equals to the translated curve. All right, so this is y equals to x squared plus 2, right? Let me just describe this as g of x. So g of x is equals to x squared plus 2, right? Notice that I added the 2 to f of x here, right? Because f of x is x squared, right? So we can describe this translation using this form, which is g of x is equals to f of x plus 2. All right. And we could also represent this translation using another form, which is the vector form. So we could describe this as a translation by the vector 0, 2. 0, the upper element here, shows that there is no horizontal translation, as in no horizontal displacement, but the bottom element represents displacement in the vertical axis. So this is 2, that means it has to be displaced 2 units in the positive y direction. All right. Okay. Now, what if I wanted to translate this 2 units horizontally in the right direction, as in, right, horizontally towards the right, all right? I'm just not writing it. All right, you know what, let me just write it. Towards the right. So how I do this is basically represent this translation by the vector 2, 0. Here 2, it basically means moving 2 units to the right, and here 0 in the bottom elements means there is no vertical displacement. So if I drew this curve, it's going to be something like this. So my bad, I didn't label this. The white one is y equals to f of x plus 2. And the green one, we could describe this translation as y equals to f of x minus 2. Okay, now notice this. There are two different things here. First, the 2 is inside the bracket and not outside. And secondly, it's minus 2, even though the translation is in the positive x direction. Now, why is this so? To understand this, let's actually find out what f of x minus 2 is. By the way, this is the proof that the f of x plus 2 actually does translate this 2 units above. See, if you plot this, it's going to give a curve which is 2 units greater in the y direction. See, all of the y values here are 2 units more than before. All right, but let's go back to f of x minus 2, right? This. Okay, so if we plotted the x and y values for this, you'll notice that the 4 here, the y value 4 occurs for minus 2 here in the original f of x curve. However, the y value 4 here occurs for the value x here in the f of x minus 2 curve. In fact, all of these values occur exactly 2 units after. So if we plotted this curve, the green curve would result, thus showing that this f of x minus 2, this translation, this is absolutely valid. All right, now we're going to cover reflection. Reflections can be on the x-axis or on the y-axis as well. If a curve is reflected on the x-axis, then the resulting transformation is minus f of x, and which shows that all the y values has been reflected on the x-axis for each x value. All right, see, let me just show this. Look at the left side only. So this is for f of x. So this is this is the f of x and y values for f of x, and this is the x and y values for minus f of x. See that all of these values are negative. So if you plot the minus f of x curve, reflection on the x-axis occurs. This is y equals to minus f of x. All right. Now what about this reflection on the y-axis? Okay. If we want to reflect a curve on the y-axis, then the resulting transformation has to be f of minus x. So here it's g of x, so I'm just going to write g of minus x. Now, why is the minus x inside here? Now let's see here. So this is the g of minus x curve, right? So if this is the x and y values for the g of x curve, which is, by the way, g of x is equals to x, by the way. And g of minus x is now minus x, right? So these are the x and y values for g of minus x. So if we plotted the g of minus x curve, this would result. And see, this is actually a reflection of the g of x curve on the y-axis. All right. The last part is stretch. You have learned in O-levels that when describing a stretch, we state the stretch factor and the direction in which the stretch will be applied. Here, if we want to stretch a function f of x with a stretch factor of a units parallel to the y-axis, then we write it as a f of x. If we want to stretch a function f of x with a stretch factor of a units parallel to the x-axis, then we write it as then the transformation is f of x by a. Okay, so first for this. All right, now why is this valid? So there's these are the original values of x and y for the f of x curve, and these are the values of twice f of x. All right, here for both of these cases, the stretch in the x direction and the y direction, we're taking a as 2. So stretch factor is 2 here for both the cases. All right, now let's see this again. So for the stretch in the y direction, this is the resulting transformation, the 2f of x curve. So it's twice x, and these are the x and y values. So if you plot this, this will result. Now notice something. Here, this is y1, right? And this is y2. This entire thing is y2. y2 is equals to twice y1, thus indicating that a stretch of factor 2 has occurred in the y direction. All right. Now, why f of x by a for the stretch in the x direction? Let's see the x and y values for f of half x. Here, it's half x because the stretch factor is 2. So we are dividing it by 2, right? Because we told the transformation is x by a. So it's x by 2. So it's f of half x, which is half x. So these are the x and y values. And if we plot these, this is going to result. Right. Now notice something. This is the x1. And this entire thing is the x2. x2 is equals to twice x1, thus indicating that a stretch of factor 2 has occurred in the direction parallel to the x-axis. All right, notice that in both of the cases, as in both in the y direction and the x direction, if the value of a is minus 1, the stretch becomes a reflection. Interesting, huh? All right. This is a list of all the transformations we have learned so far, all summarized in the table. Feel free to pause and note this down or take a screenshot. Okay, now we're going to solve a problem. Given that f of x has been mapped to thrice f of twice x plus 4 minus 5, describe the transformations that took place. All right. we are going to identify the transformations first. Here, 3f means a stretch of factor 3 in the y direction. Here, twice x means a stretch of factor half in the x direction. This plus 4 means a translation represented by the vector minus 4, 0. And this minus 5 represents a translation represented by the vector 0, 5. 0, minus 5. All right. So we identified all the transformations, but which one is happening after which? Well, it so happens that there's a proper sequence for all the transformations. We always go from inside to outside. So the transformation which happens first is the one which is closest to x here. That is the 2x. That's the stretch in the x direction first takes place. Then the plus 4, the horizontal translation in the negative x direction. Then the stretch factor of 3 in the y direction here in the y. So this happens next. And then finally the minus 5 here, the vertical translation of 5 units downwards happens the last. All right, so that's all for today. We have covered, whoa, what just happened? Yeah, I'm just going to erase this because this looks very bad. All right, so that's all for today. We have covered all the types of topics of functions with this third and final video. Hope to see you guys in another video series though. My name is Marzukh, and this was Functions. Later.